Calculate the volume of the solid generated by rotating the region between the curves y equals 4 minus x squared and y equals 0. This is rotated about the line y equals -2. This problem starts out by getting a good drawing of the region. Y equals 4 minus x squared is a parabola that opens down, and it's been shifted up 4 units. So it hits the y-axis at a maximum of 4. Y equals 0, that's just the x-axis. And we're rotating this about the line y equals -2. When we go and do that, we see that we have this hole, this bead-like shape with a hole in the middle. Our region is not flush up against the axis, so if we're going to do it, it would be in washer if our choice is between disk or washer. So what we do is we draw a typical rectangle that is perpendicular to the axis of rotation, and that will generate the volume. We need to find the outer radius and the inner radius in order to find the formula for the washer, volume by washers. The outer radius is found by drawing a line from the axis of rotation up through the region. And so what we also notice is that we decided that it's going to be washer, but we need to make a note of what variable it's in. Since the rectangle is vertical, it gets moved horizontally in x, and so this should be set up in x. This outside radius then changes as x changes, and so it actually has to be thought of as the sum of two distances. There's a distance that goes up to the x-axis. This here is the x-axis. And then there's a distance that goes up from the x-axis to the curve. This distance up to the x-axis is just the constant 2. The distance up from the x-axis to the curve is always the value y. But since it's an integral that's in x, we just put the formula for what y is, 4 minus x squared. And so this outside radius is the sum of these two distances. It's 2 plus the 4 minus x squared. And we could put the 2 and 4 together to say it's 6 minus x squared. That's the outside radius. The inside radius is found by drawing a line from the axis of rotation that comes just up to the region. It's not shaded, but our region is this region that I just drew these dashed, these red lines in. So we're going up to the region. What we need to recognize is that is a solid distance. That distance there doesn't change. It's a constant. As we move from left to right, that distance will always be 2. So that is your inner radius. And so we go to set up washer by taking this outer radius and squaring it, and subtracting from that what we get when we square the inner radius. And that's what we integrate from a to b. The a is the lowest possible x, and the b is the highest possible x. And if we didn't know it, we can find it by trying to find where these two are equal to each other. And so that's at plus or minus 2. So minus 2 would be the a, and positive 2 would be the b. And we're integrating 6 minus x squared, quantity squared. Multiplying that out, we get 36 minus 12x squared plus x to the 4th. And don't forget though that we need to take away from that 2 squared, which is 4. The 36 and the 4 combine to give you 32. So we're integrating 32 minus 12x squared plus x to the 4th. But we need to recognize that we're integrating it from minus 2 to 2. Be on the lookout for whenever you integrate from minus a to a, check the function that you're integrating to see if it's even or odd. You can simplify things then. A polynomial is even if all the powers are even and perhaps there's a constant term or not. And so this is an even polynomial. If you were to graph it, whatever would be on the left hand side of the y-axis would also be on the right hand side of the y-axis. So if you're trying to find the area from -2 to 2, that left hand area will be the same as that right hand area, so we can instead do it from 0 to 2 and double. It's just more desirable to have 0 as a lower limit, especially when integrating polynomials. Plugging in 0 ends up something that's academic. And so here we have it. This will give us the volume, and we just use the power rule in reverse, 32x. When we get the second term, we get x cubed over 3, and the 12 and 3 cancel to be a 4. And then we get x fifth over 5. That's the antiderivative. And we need to use the fundamental theorem where we plug into the antiderivative, the upper limit, and from that we subtract what we get by plugging in the lower limit. But plugging in the lower limit just gives us a 0. And so plugging in the upper limit, we get 32 times 2, and that's going to be your 64. 2 cubed is 8, and 8 times 4 is 32. And then 2 to the 5th is 32. And so we're looking at 64, take away 32, add on 32 over 5. Whenever you can, you want to put together things that are alike. So 64 minus 32, we just subtract that and get 32. And now, instead of putting everything over 5 and trying to multiply 32 times 5, what I want you to recognize is the fact that you can factor out a 32. They both have it in there, and it makes the calculation much more simple. Because then when it comes to the fractions, after taking out the 32, you'll be just left with 1 plus a fifth. And it's just so much easier to combine 1 plus a fifth than 32 plus 32 fifths. Okay. And so 1 is 5 fifths. 5 fifths plus 1 fifth is 6 fifths. And then the 32 and the 2 on the outside multiply to give you 64. And so we're done when we just multiply 64 by 6. What we get from that is 384. Yeah, so this is 384 pi over 5 for your final answer.